Well, hello, wonderful students. This is going to be an experiment, but this is the day before fall break, and I'm going to try to hustle to always get you these pre-help videos. But I don't want them or intend them to replace working through the course. I don't want them to. Oh, yeah, 406. There we go. Perfect. I was like, what's going on here? I don't want them to, skip the hard work that I do hope you continue to do so you can learn and grow. Because remember, math is about learning, not performing. Just reach out to me if you have concerns about your grades. Yep, you might have to listen to me ramble and talk about the math. You might have to type something in chat, but we're going to learn, we're going to grow, and that's the whole point. Okay? All right. Remember, check out your announcements page. I'm going to start here, so you might be right here. There's fall break, woo woo. And then we're going to go down to 30-minute help sessions. So this is going to supplement those 30 minutes, and we'll kind of go from there. So here we go. The first video, if you're watching this out of order, this was the first video I made trying to make this new system work. So again, please don't use this as a way of skipping working through the lesson, because it's going to be incredibly important now that we get shorter classes, that you're able to work through the lessons too. You learn how to use the lessons to complete some of the learning. It's a great way to get ready for colleges, even community colleges. So many, even if you go in person, they then say, go log in here, and this is where you do your homework. So get used to it here, and you'll be ready to achieve whatever else you want to do outside of high school. This is what we look at. This is kind of how our curriculum is tied into the live sessions, is tied into our state standards, okay? So they want you to this lesson learn about the remainder and factor theorem for a polynomial. This is pretty cool. So we just did, hopefully if you're on task, if you're caught up, or if you've been with me, if you've just joining, then you didn't do it, but maybe you've done it. So think about reviewing, reach out to me for a review. We've done polynomial long division and synthetic division, and we end up finding a quotient. Well, and we'll talk about this some more, but the big idea here is that if the remainder is 0, that last number in synthetic division, or if you do the polynomial long division and you subtract and your final one is 0, everything is subtracted, cancels, as we like to say, then the remainder is 0. That's pretty cool. That means your divisor and your quotient are factors of the dividend. That's kind of the big idea. But then a cool thing happens. Hey, if you remember that form of x minus a, think of synthetic division. Well, if we take that exact value a, just a, right? So if it's positive, then a would be negative. And if it's negative, the opposite of whatever it is, okay? And you plug that into your polynomial, P of a, meaning wherever you see x, you replace this number a in the polynomial, and then you cube it, square it, whatever, multiply it by its coefficients, and then finally your final number, if it's 0, then it's a remainder. If it's a factor. Okay, so the remainder theorem and the factor theorem are going to come into play here, because the remainder theorem says you can take this, if the divisor is in this form, and plug that value in, the final answer will give you the remainder. That last number in synthetic division, or the last number when you do polynomial long divisions, and then that is the remainder. That's pretty cool. And then if it's 0, it's a factor. So that's how those two work together to help us solve polynomials. And when we think of solving, we're trying to find values of x that make our polynomial 0. Okay? Again, you have some wonderful videos, some different stuff here. I'm going to click quickly through this. So I apologize, but most of these new videos will start like this, where I'm going to review what you guys see asynchronously. So normally I don't really see this with you guys. You do this asynchronously, and then you go down here. So this is evaluating expressions. This is great. This is a review. If you know this, feel free to move on. If you don't, if you're like, this is intimidating, try it. Okay, try it. Let's see, what does it say when a equals 8? Well, that's a. I'm just going to replace it. Well, 2 times, then you just start following. That's 16. Well, that should be 4, and the final answer should be 10. Boom. See? the green checks. That feels nice. Got red X's, no big deal. Think about it. Okay, again, check out here. They'll give you this. They have a little video if you need help, and then move on. Just a quick check, because math builds. And if the skill is kind of shaky, you have an opportunity to re-practice it there, because that's what we're going to do. We're going to take the divisor, whatever the x minus a is, we're going to substitute it into the polynomial, and we're going to simplify the steps till we get to an answer, just an actual number, 10, 0, -5, whatever it is. That's how we're going to use the polynomial remainder theorem. But anyway, you can watch the videos. I don't want to watch those with you. If you see this, pick either one, whichever one you feel like you would like to do. I'm going to always pick on level, because that's my goal. Is if you're not on level, let's hustle, we'll work hard, try to bring you up to on level. Otherwise, if you need a support level, I'll be your support level. In the asynchronous time, go ahead and click that. But then let's meet, stay after class, reach out for one-on-ones, practice. Key concepts. This is what I was rambling about. But now, without rambling, there's actual words here on this lesson. If you're asked to find p of 2, that's p of 2. It's a function notation saying p representing some polynomial. We don't know yet. Parentheses of 2. So polynomial, whatever you have, your expression of 2 is saying we're going to replace 2 into wherever we see x. That's why we did that quick check on how do you evaluate an expression. So p of 2, for this polynomial, p of x, 2x to the fourth plus x cubed minus x squared minus 2x minus 3, you would use substitution and evaluate the function as follows. Oh, cool. Okay, great. So that's what I'm talking about. Now, the polynomial remainder theorem, are you kidding me? They want you to divide, but that's fine. To me, this is pretty straightforward. In certain situations, long division might make sense, but it's a good thing to practice. And it's a neat relationship. It's just neat that you could make this p of 2 into a factor, a divisor, or an expression that is a divisor, and then use polynomial long division or synthetic division to find the evaluation, the answer. Sometimes it'll be quicker, sometimes it won't. Okay, so that's the key idea behind the polynomial remainder theorem. Take a look. If you have the polynomial p of x and it's divided by x minus a, then the remainder will be p of a. It's got an interesting proof. I think they go over it in here of why that will work, why that makes sense that would work, and it will always work. So for those of you who are interested in the why behind the math, check it out, try to follow along, recreate it on paper. That's really how great learning is done. Okay, in other words, if you do polynomial long division, or in this case, synthetic division, which is totally fine, because now our a will literally be right there, positive or negative, you just place it there. Do synthetic division, right? We bring it down, multiply, 2 times 2, 4, add 5, 2 times 2, and repeat. 10, add -1 plus 9, 2 times 18, add 16, add. The remainder is 29. Well, guess what? Look, it's the same as if you plugged in just the divisor value, a or k, into your polynomial. So that's the process. These are two different ways to find the same answer. Okay? Now you can do it for -2. You just put -2 down here and do synthetic division. So maybe that's quicker. I don't know. Maybe it's easier because you don't have to deal with squaring, adding, subtracting, all that stuff. You just do the pattern, bring down the first number, multiply, -2 times 2 is -4, add, -3. Do it again. -2 times -3, +6, add, 5. Do it again. -10, add, do it again, 21. So the answer, and you can check it, if you plug this into these where you see all the red spots and then you simplify, you will get 21. Well, cool. So that's the both directions, how to use it, what it means. It's a theorem. It will work. There is a proof. Here you can practice yourself. Again, here's some worked examples. Again, right? Notice the zeros as placeholders. That's important. Look how many skills you're practicing when you practice this math. X to the fourth. Well, we're missing x to the third. We're missing x squared. And then there's our x term and our constant term. You still need those zeros as placeholders when you use this to make sure you get the right answer when you're done. This is an algorithm, which means there are steps to follow the process to get to the right conclusion. Programming uses algorithms quite a bit. You just start with the right process, you follow the steps, and you will get to the right answer, provided you don't make any mistakes or have an error or a glitch. Maybe you glitched. Oh, we glitch. Okay, so anyway, those are beautiful practice problems. They write it out. Those are for those of you who might learn better by reading text versus watching videos. This is a beautiful way to do that in your online lessons. I've decided I'm not going to do this. I am going to just kind of key in on a highlight of ideas for time's sake. But you give me feedback because we just worked through the entire lesson. We're already at the summary. They ask you some pretty cool questions. If you used the polynomial remainder theorem, a polynomial function is evaluated at 0. What is the divisor of the equivalent division problem? Oh, that's a good one. Remember, we're going to x minus a is the same thing as f of a. If you divide, hold on, the remainder when you divide by this is the same thing as the value if you evaluate at a. So now they're asking, what if it's f of 0? Well, that means a, right? A equals 0. So what will the divisor be? Just x. X minus 0 is just x. That's pretty cool. All right. Given that function, for what value of x would it be useful to use the remainder theorem? I don't know. That's up to you. Show that when f of x, that expression is evaluated at f of 3 is the same value using the polynomial remainder theorem when evaluating the function conventionally, meaning just plugging and chugging, as I say. Which method is more time efficient? Cool questions. Those are for you to think about and decide for yourself. I, of course, have strong opinions if you haven't noticed. Apply it. Practice what you've learned. Cool. I do like looking at these. I'm pause it. Okay, so I was just reading. They're just basically telling you they came up with a model to approximate the number of countries that attended throughout the year. So based on the data, this curve of best fit is what they showed. So before we even take a look at this, I just want to always encourage you to stay curious. They're telling you something, and I would hope, I'm kind of checking on them now. Hey. What? Okay, that didn't work. So let me go back, apply it. This, control copy. Okay, remember we need to make those exponents. Okay, so here's the curve. It only really makes sense to look at it from 0 on, right? Because, well, in this case it does. Think about what it means. So now let's go back. Let's talk about this. The years between 1980 and 2012. So what is that, a 32-year span of time, right? So from 0, what would 0 represent? It should represent the year 1980. So the starting point of 85 countries. So thinking about what this means, the model means. So now we know that, okay, starting in 1980, there was approximately 85 countries that attended the Summer Olympics. And then they figured out that this curve is going to demonstrate for the next 32 years what's happening. Oop. Okay, so we'd have to change our settings here. We'll go to like -1 to +35, and we'll do a step of 1. Here to the minor ones. And then for the y-axis, I don't know. Let's see. Let's do 70 to, I don't know, 300 with a step of 10. Okay, so now what do I see here? So let me move my face out of the way. Down here will be the difference in years from 1980, right? We started here. And then look how it grows. That's a believable curve. I could see that as a believable curve as we're going through, and then go over to 2012. Where would that be? Like right around here. Okay, so there's many ways to think about problems and approach problems, but this was a real world situation. So why these crazy numbers, why a cubic function? Well, because they probably plotted all these points and realized, hey, for this chunk from here to here, this is the curve of best fit. So now we can make a prediction on how many we might think are going to come in 2013, right? It's like for many years. And again, it's an approximate. Obviously, we don't have fractions of countries. Either the country joined or the country didn't. But again, it's an approximation. It shows the growth. It shows where it's kind of plateauing. And maybe we can expect it if it's going to continue the trend. I don't know. We might say this is unrealistic. But anyway, okay. That's what I wanted you to think about there. We're going to move on. So lots of interesting things. Think about it. Stay curious. If you're not even there at that level yet where you can check the graph, what does the graph mean? It took me forever. I still make mistakes, so I'll still get confused as to what the math is actually representing. Use the remainder theorem so for me, you could evaluate this, right? Watch this. Control copy. Go over here. Control V. This needs to go up. This needs to go up. 2. We'll get rid of that. Right. So that's our equation. And then you can just replace, what is it? When F is 3. So now you're just going to have times shift 3 times highlight 3 times highlight 3, and it should be negative 65. So that's the traditional evaluation where I replaced the value. Cool. They use synthetic division and they found the remainder. So we'll do that next. Synthetic division. So 8 is our divisor because it says f of 8. So we're going to do 4, negative 30, negative 16, 3, negative 25. Did I do that right? Let's see. 4, 3, 2, 1, 0. Yep. So I don't need any placeholders. That's what I was checking. I was checking the exponents, the powers, and I was making sure they were in decreasing order and nothing was missing. Like we didn't jump from x to the 4th to x squared, because then I would have put a 0. Okay, synthetic division says you just bring it down, multiply, and add. Ooh. Check my work. I did that very fast in my head. Basically, bring down the first number, 4, 32, add them, right there, 2, multiply, add them, 0, 0, 0, add them, 3, 24, add them, negative 1. Go slower, follow along, make sure you see what I'm doing. Alrighty, try the answer in each box, match each function with its value. I'll let you try this one on your own, but remember you have 1, 2, 3 different things to divide, evaluate. Truly, it's up to you how you want to solve these, and you can check your answers right there, right? I mean, we can just throw stuff in there and hit check answer. Ooh, I got one right. Anyway, let's see. Ooh, we're getting closer. Okay, anyway. That did nothing. That was just an example of, like, I know that it's possible to do that, but these aren't where the points are coming from. These are practice problems where you are safe to fail and try. Getting these right don't help you if you're not actually doing the steps. Boom, boom, boom. Getting them right when you do the steps or getting them wrong when you do the steps, both situations help you tremendously. Okay, let's keep going. I'm very thirsty. On your own, I'm not doing any of these. You guys do these. Well, there you go. So this is your mini lesson for 406. Try that on your own. There is no quiz apparently, so it's a great time to practice. So thank you for watching. I look forward to your feedback on what you think about these videos and the video quiz apparently that I'm going to build right after this. Thank you guys so much.